everyone, this is Sukruti Joshi from LG Institute of Engineering and Technology, Ahmedabad. I'm going to take the subject chemistry. The subject code for it is 3110001. Here, in our previous session, we have started our chapter number 1, which is general chemistry. In general chemistry, we have seen different kinds of bonds, their examples, their types, structure of the atom. Along with it, we have observed a particular kind of shape and coordination number also. The first shape that we can take here is linear. In linear shape, we have to see that the particular compound should be stable one. As for an example, you can see here CO2. CO2 is an example of linear molecule. It has a bond angle of 180 degrees. Along with it, we can take the example of HCl, HBr and HF also. Right? Next is trigonal planar. In this shape, all the molecules, like mainly 3 different atoms, combines with the central atom and they form a trigonal shape, but it's a planar one. We can take the example of BF3, we can take the example of SO3 here. These are very common examples of trigonal planar shape. Here, the bond angle is generally 120 degrees, right? Next is tetrahedral shape. Tetrahedral shape's best example is CH4. Methane shows the example of tetrahedral. Here the bond angle is generally 109 degrees, right? Next shape is octahedral. In octahedral, we can take the example of SF6. The central atom will be attached with another 6 atoms here. As you can see in the image, SF6 has the bond angle of 90 degrees. So as octahedral will also have 90 degrees bond angle, right? So in this manner we can see that how the attachment of the atom changes the shape of the molecule. So depending upon that, their bond angle will be different, and as the bond angle changes, along with it, their shape also changes. Now, next one, our next topic is hard and soft acid and bases. What is the meaning of this HSAB theory? This theory is generally referred as HSAB theory. So, we can have our Lewis bases, or Lewis bases generally can be divided into 2 different categories. Right? Number 1, hard bases, and number 2, soft bases. So what is the difference between hard bases and soft bases? Let's observe it here. Hard bases contains small, relatively non-polarizable donor atoms. So bases are generally donors as they contain a higher number of electrons. Okay. While soft bases contain larger and relatively polarizable donor atoms. Again, remember it particularly, bases are generally donors and acids are acceptors. Remember it properly, okay? So, the metal ions with the highest affinities for hard bases are hard acids, okay? Generally, it has been observed that hard bases combines with hard acids as well as soft bases combines with soft acids, right? Their affinity, their match is very perfect. Whereas the metal ions with the highest affinity for soft bases are soft acids. So in this manner we can say that soft attaches with the soft while hard attaches with the harder one. Right? Now let's take a look at another one. Let's take a look at the examples here. Let's take an example of hard acids and soft acids first. So H plus, Li plus, Na plus, K plus, Ca and Mg plus. These are considered as hard acids. While another one soft acids. So Cu plus, Ag plus, Au plus, Pt plus as well as Hg plus. They are considered as soft acids. Right? As you can see it in the image, harder ones can easily accept the electrons. Here they are acceptors. Okay. Likewise, let's move on to the bases. Hard bases involves OH minus, Cl minus, NH3, CO3 minus 2 and PO4. Likewise, soft involves Cn minus, SCN minus and I minus. Okay. Let's move on to the next point here. In our next point, we have periodic properties and periodic trends. We all know that periodic or periodic table is basically a very important one for each and every chemical analysis or any kind of chemical study. So here, if you can see in this particular periodic table, it shows you each and every property of individual element. We can say them atom also. So, periodic trends are specific patterns that are present in the periodic table that illustrate different aspects of certain elements. For an example, their atomic sizes. For an example, their electronegativity, their ionic sizes or nuclear charge, etc. We will study them one by one as well as we will study their trends also. Now, our first one is electronegativity. So, what do you understand by electronegativity? Electronegativity is the ability or a chemical property of an atom to attract the electron towards itself. It's an ability of an atom to attract the electron towards itself. As the electronegativity value increases, their acceptance also increases or their attraction increases. Right? So, it's a measure of an atom's tendency to attract and form bonds with the electron. Generally, it has been observed that the elements on the left side of the periodic table requires more energy to gain the electron. This is a general observation. We can take a high electronegative elements example as the halogen series, F minus, Cl minus, Br minus and I minus. Let's observe their trends. So, when we move from left to right, the value of electronegativity increases. And when we move from top to bottom, the value of electronegativity decreases. Here, two exceptions are also there. Noble gases and lanthanide actinide series. They are referred as exceptions because they don't follow this trend. Okay? Let's move ahead. Our next property is ionization energy. So what is the ionization energy? Ionization energy is the energy required to remove an electron from an atom. So ionization energy is exactly opposite to the electronegativity. There we are talking about attraction. Here we are talking about loss. Okay? The lower the energy is, the more readily the atom becomes cation, and therefore the higher the energy is, the more it becomes cation. Okay? So Here, let's observe the trends. When we move from left to right, it increases. And when we move from top to bottom, it decreases. Again, here we have exceptions like noble gases as well as lanthanide-actinide series. Our next property is electron affinity. Again, hear the word electron affinity, right? Electron affinity is the ability of an atom to accept an electron. Okay, here understood the difference. Electronegativity means attract. Electron affinity means accept. Okay? Here electron affinity generally decreases down group of elements because atom is larger than the above it. Generally it has been observed a different trend than that of the normal one. Okay? Let's observe the trends here. So when we move from left to right, it increases. And when we move from top to bottom, it decreases. Again, here two exceptions. One is noble gases. Second one is lanthanide-actinide series. Okay. Next one or next periodic property that we will study here is atomic radius and sizes. What is the meaning of atomic radius? So, the atomic radius is 1/2 the distance between the nuclei of two atoms. Just as we decide the radius is half of the diameter of the circle, right? This distance is measured in picometers and observed through the periodic table. Let's see their trends here. Generally, when we move from left to right, they decreases, and when we move from top to bottom, it increases. Okay. Here also we have two exceptions. One is noble gases, another one is lanthanide-actinide series. Now, let's move on to the next periodic property, which is oxidation states. Okay, oxidation states actually plays a very important role. How? So, here when we talk about oxidation states, it has been observed that they can be different for different kinds of elements, right? Next one is atomic radius and sizes. Next we will learn in our next session.